solving day 8. Now we are continuing with day 9, and as we saw already in day 8, the challenges start getting quite complicated. Okay, this one has very short input. Let's give a try with firstly with ChatGPT, and second here I have, as previously, I'm submitting of my solutions there in my repository. Let's copy day 1, day 8, part 1, and let's have it rename to day 9 part 1. If you're new to my videos, what we're doing here is simply having the structure of the project as the given day. Each part is in separate folder. In some of the cases I have revisions that I'm looking for a better solution, or as here in part 1 of day 8, initially I wasn't able to solve the problem, and after trying more than an hour I stop and continue another day, and I kept in my repository everything that I tried to do and so on. The structure of the project is we have simply main go file. We are reading the input from a current file because we consider each part as its own main file, and we have input, which is my input from the given day. We have the test input, which is part of the description of the problem, and probably the most interesting part that we have are all of the prompts that we have attempted. And here is, for example, we have tried with prompt with Bing and so on, and initially in our initial attempt I think we try with context, instruction, task, something like that. We'll probably do exactly the same thing. When I'm asking ChatGPT, what I'm trying to do usually is giving a context. For example, we're saying that you're a prominent computer programmer, you have read all the books from Donald Knuth, and you solved all the problems in them. Probably we should remove this part for Donald Knuth. Seems not helping, although it's cute. You have been invited to participate in programming competition. You're given a problem to solve, and let me start a new chat, put that like a context, and now we have the bot, so to say, set up for our challenge. We can do the same with system messages and so on. Here we have let me give the answer. So far that's the answer, and prompt 2, we have our instruction. We want to have day 9 part test, and we want to be a Go program, and here are the description, and the description is simply copy and paste from here. let's try that and see how ChatGPT will do with this input. We're getting, as we can see, some heat map that looks reasonable. Some description, will not read too much about it. Let me grab the code and have it here as an answer for ChatGPT. So far, as always, we don't read initially the problem, or we scan through and firstly get some kind of solutions. We'll evaluate the solutions, we'll simply run it with some test input, and then we'll go through the problem. When I'm saying test input, here firstly I'm grabbing the code is here. Of course, at the moment our test file it's empty. We need to go back to the challenges and take a look a little bit for the task. We're in if you haven't seen my previous videos, we're in submarine, and we're under the ocean. We were escaping from some different creatures. We have some that were helping us and so on, and we were lastly in a cave, and now we are continuing. This cave seems to be lava tubes. Okay, that's a volcano cave, and part are even still volcanically active. Okay, we can go to the places that are deadly. Small hydrothermal vents release smoke into the caves that slowly settles like rain. Okay, if you can model how the smoke flows through the caves, you might be able to avoid it. Okay, we need to avoid this smoke and be that much safer. The submarine generates a heat map of the floor of the nearby caves for you. Your puzzle input. Okay, we have here the smoke and some indicators that are saying, okay, in this position it's high, for example 9, and low 0, and so on. Smoke falls to the lowest point of the area 18. For example, consider the following heat map. Okay, we have this heat map. Each number corresponds to the half particular location. Okay, we know that 9 is very high, which means that well, the smoke will not flow there. Each number corresponds to the half particular location where 9 is the highest and 0 is the lowest. A location can be your first goal is to find the low point, the location that are lower than any of its adjacent location. Okay, I need to find, for example, here it's marked 5 because it's smaller than all of the ones that are connected with. Here 1, here 0. The location that are lower than any of its adjacent location. Most locations have 4 adjacent locations, up, down, left and right. Locations on the edge or corner of the map have 3 or 2 adjacent locations. You can be here, you have these ones, or having a 3 here. Okay, obviously we probably missed the diagonal. Diagonal location do not count as adjacent. Okay, and what's our goal? In the above example, there are 4 wow points, how highlighted. 2 are in the first row, 0 and 1, 5 and 5. However, the location on the heat map have somehow adjacent locations, so are not wow points. The risk level of wow point is 1 plus its height. For example, 5 will be 6 and so on, and we need to add them. First we need to find all of the points, after that to add the counts, and for each one of them to add the count. Okay, that's our task. Let's grab this test input, and for that one we need to get 15 as an answer if our program is working correctly. I'm going to turn that. Let me close some previous exercise that I've never closed. Okay, and let's see what we get. We get 15. Let me try with input. Before to try with the input, let's get it. Here it's our input, significantly bigger one. Hop. Okay, we get this number. Let's give a try. Okay, it doesn't work. And now let's see why it works with the initial value, but it seems to be failing with the higher value. Firstly, where we make the sum. Okay, let me go back to the test and have the heat map up here. Once we produce it, simply to verify that everything is as expected. Okay. We have 219. Let's take a look in our demo example. 219.
Das Top-Ergebnis im Internet sagt.
1 second to stop my Google Assistant. You shouldn't use it. It gets confused and it's thinking that I'm saying the Google free key phrase. Okay, I have 2 and 0 that are these corners. Let me see if I have 9s and 8s that are the was. Okay, I see that I'm parsing it correctly. Let's double check that's the case for my ginormous input. We start with 9 and we have 7 at the end. 9 and 7. Let me look here. 9 and 7 looks legit. Ends on 8. Yeah, is and starts with 4. Okay, absolutely fine. And I would imagine that here the problem is not counting some. Okay, we are going to firstly all of the rows. Let me go back to the one that is correct and simply we get the correct value, and it's easier, smaller and easier to debug. We're getting 15, and that's because in our example here the points are here, edge case and so on. What I'm thinking is simply here to add another one that is 0 to see that it's covering this diagonal, because our points are only on this one, and I want to, okay, let me firstly verify the edges. I will put here 1, and that should increase the number with 1, I think, yeah. Do we get this edge correctly? No, it looks correct, because it's 1 plus 1 of the height, it's 17. Okay, we're covering this corner, from this side the corners. What I'm more interested, if I turn it back to 9, is the same here. Again, one should not change the other outcome, but simply will bring this one. It's still, I have run the program, it's 17, which looks fine. What about if I go here, somewhere in the middle, 8, 8, yes. Again, seems legit. 15, okay. Now, one thing that I haven't checked is, for example, what if the number next to each other are the same? Because in this example we have for example, what if here we had, instead of 2, 1, and probably read correctly the conditions, we're getting 20. Why we're getting 20? Because that's the smallest, it's adding 2, previously was 1. Now this one is also the smallest, and this one is also the smallest, and we add 6 because the one that was 0 was counted as a 1, it's 20. Okay, which means that at the moment we count out the one that are with the same value. But is that is here a part for equal one? What we do when they're equal? Location that are lower than any of its edges on location. Most location have 4 edges on location: up, down, left and right. Location on the edge or corners of the map have 3 or 2 edges on location respectively. Okay, we don't count diagonal, but let's simply test. Do we really don't count diagonal? Here we have this 5. What if we so this 5 in here, if we put instead 4, that shouldn't change anything because it's smaller, but it's on the diagonal. We should get our original 15, and it seems like this part it's legitimately working. What about do it here and so on? Here, is there information? There are 4 wall points highlighted toward the first rows. All the locations the heat map have some over just some location. So or no wall. Let me avoid and that much safer the submarine. To find the wall points, the location that are lower than any of its adjacent. Lower, which means that with here having that to 1, that's not that should actually change our score to less. Why we don't do that? Where we are checking is our position. We having INJ, so is our position. Why would we will send our point? Oh, that's our map. And we're checking our I and J, that's our current position. When we're here, that will be it probably will be even better on if we have it only like that. Written very small corner, and if I run the program, I'm getting 6. However, I shouldn't here there is not a single one. I should get 0 because there it's all of this one are equal, and I think it's lower than any of its adjacent location. If it's on the same level, it's not it doesn't count as a lower, but here we have it implemented in a way that it's counting it exactly like that. Let me do that, and let me debug. Run debug, and we're stepping here, we're 0 0, and that's on 2. What's happened if we jump over? We are not there. we are not there. And we're here, which what we're checking. Okay, the one that is on this side. Is it bigger? No, it's not. We're returning false. Okay, that's exactly what would we expect. If we step again, we're here, we're 0 and 1, which is this one. In this case, we should still get false. Let's see what's going on wrong. Here, this check is fine, this check is fine. Why is this check fine? We're checking that our index is above 0 to be able to look at this side. Here we're getting, okay, our index is smaller than the length and -1 because we want to add it. The same kind of logic here. Why we return is wow point. We're getting true. Okay, I see. Because here we should have an equal everywhere. That was the bug. Should read simply the code instead of let me return before to return it, to go here and actually return the original file path. Hop. Okay, perfect. It's exactly what I would expect. And with this one, all looks fine. And when I have that was our original one. Okay, everything looks absolutely legit. Bye bye input. Okay, we're getting much smaller number. Let's give a try with this number. Okay, that's solve our task for day 9 part 1. See you in part 2. Have a nice day.